In part 3 of Unit 3, we're going to talk about stoichiometry. Alright, let's talk about the real use of stoichiometry. When we're given a reaction and amount of either a product or a reactant, we can use what's called a mole ratio to find the amount of product that's going to be made in that reaction. We can find the amount of another reactant needed to make a certain amount of product. The mole ratio, it's the coefficient of two substances from the balanced equation. Remember, when we're given masses of reactants, we can't go through some dimensional analysis directly to masses of products. We've got to convert the mass of those reactants to moles, then use this mole ratio step, that's the ratio of the coefficients, then convert from moles of the product to grams of the product. So let's look at an example here. First off, we have to balance our equation. We can't have a mole ratio without a balanced equation. So to balance this one, we're going to need to put a 2 in front of NH3, and that means we'll have to put a 3 in front of H2. Now let's assume, just a question said, you're given 2 moles of hydrogen. How many moles of NH3 can be formed from that? So we're starting with 2 moles, trying to find the moles of NH3 that can be formed. In any stoichiometry calculation, you have to be given some value to start with, so that's what we're going to start with writing down. 2 moles of H2. Our units are already in moles, so we're going to go straight to the mole ratio step. The point of the mole ratio step is to go from moles of what you have to moles of what you want. We've got moles of hydrogen. We want that to go away, so we're going to cancel it out by putting it on the bottom of our conversion factor. We want to get to moles of NH3, so we're going to put it on the top. Now the numbers that we put with this conversion factor are the coefficients for those things from the balanced equation. There's a 3 in front of H2, so we put a 3 down here. 2 in front of NH3, so that 2 goes up there. Moles of H2 are going to cancel out, so my answer is going to be in moles of NH3. So to solve this, it's 2 times 2 divided by 3, which you should end up with 1.33 moles of NH3. Again, that's a very simple example because we could go straight to the mole ratio step right here. Usually, there's work before and after the mole ratio where you've got to convert into moles and out of moles again. Let's look at a slightly harder example. Let's say that we've got 2 grams of C2H4, and we want to figure out how many grams of CO2 are going to be produced from the reaction of these 2 grams of C2H4. Again, our first step has to be to balance the equation. 2 carbons, we need to put a 2 right here to take care of that. We've got 4 hydrogens, so we've got to put a 2 right here to take care of that. And putting a 3 here will balance out the oxygens. We've got 4 plus 2 oxygens, so this will give us 6 total. Now that our equation is balanced, we can start the actual stoichiometry. Start with our 2 grams of C2H4. We're not in moles, so we've got to get there. We have to convert grams of C2H4 to moles. 1 mole of C2H4. To find the molar mass for that, you add up 2 carbons and 4 oxygens. It's 26 grams per mole. Now that we've got moles of our reactant, we're going to use the mole ratio. We're going to get rid of moles of C2H4 and get into moles of what we're trying to find, moles of CO2. And the numbers we put in this box are the coefficients of those things from the balanced reaction. So we're going to take this 2 from CO2, put it there, and this invisible 1 from C2H4, put it there. Now we've got moles of CO2, but they didn't ask us to find moles of it, they asked us to find grams. So now we've got to convert from moles of CO2 to grams. 1 mole of CO2, 1 carbon, 2 oxygens, has a mass of 44 grams. Make sure all of our units cancel out. The grams of C2H4 are going to go away, moles of C2H4 are going to go away, and moles of CO2. So we've done our dimensional analysis right now, we just have to solve it. 2 times 44 divided by 26, and that should give us 6.77 grams of CO2. We don't always have to use mole ratios going from left to right across a chemical reaction. We could do a mole ratio between reactants. When we did that, we wouldn't be finding how much product is made. We'd be finding how much of reactant B we need to get rid of a known amount of reactant A, or the other way around. We could also do it between products. We could do the mole ratio between C and D. If we know how much of product C is formed, we do the mole ratio between C and D to find out how much product D will be formed in that same reaction. The ratio between reactants and products is going to calculate how much product is made from a given reaction amount. That's what we did on the other side. Started with a reactant and went to a product. Or we could do it in reverse. We could start with a known amount of a product and go backwards to find out how much reactant we would need to make that amount of product. Your question for this section: 6.5 grams of aluminum reacts with excess oxygen. How many grams of aluminum oxide are formed?